Hi, everyone. This is joint work with Rakesh Agrawal, who's now at Data Insights Laboratories, and Behzad Golshan, who's at Boston University. And we actually started this work about a year ago back at Microsoft Research, Silicon Valley. So I'm going to be talking to you about where do social networks belong in web search. And, you know, paper gets accepted in KDD. I search for Sydney. I'm so excited. I go to my favorite search engine, whichever one like me might be, and I search for Sydney. And so here is Google on the left, Bing is on the right. I could have flipped them, and you might not notice the difference. So there is empirically a huge amount of overlap in very popular queries that you might observe when you try to find information in those two, the largest search engines. And so this talk is, first of all, about quantifying these differences. And for that, we introduced two data mining tools to help us. We do a case study of Google and Bing because there are a lot of studies that have, in the past, but they're mostly outdated. They refer to search engines that don't exist anymore. And so we chose to rerun the studies and see at this stage how much this overlap is. And at the end of the talk, we're going to see whether we can use social media and Twitter in particular in order to sort of diversify the information that users can access on the web. And so without further ado, let me first talk a little bit about the data mining tools that we introduced in order to do that. So the first tool we have, we call Tensor Compare, and it's based on tensor analysis. I'm going to define that in order, if you don't know what that means. And it gives us some sort of clustering, visualization sort of perspective of different search engines and helps us understand differences and similarities. And the other tool we call Cross-Learn Compare, and it's based on a simple machine learning idea. And it further quantifies the overlap in the results of search engines. Both assume some kind of feature representation of the results, which I'm going to leave vague for now, but I'm going to exactly define what that is after I describe the tools. And so first tool, Tensor Compare. So a tensor is simply, for all intents and purposes of this talk, a multidimensional extension of a matrix. And in this case, I'm showing you a 3-mode tensor. And let's say we have multiple queries. And we get a result per query, which we represent in a feature space. So if we have multiple search engines, then we have a query by feature by search engine tensor. Now, we usually have a time component here because we might probe the search engines every day, let's say. And so we have a 4th mode, which I'm not able to show to you, but it's there. And so this is a tensor. And normally what we do with this is we analyze it into latent components. And so each one of those, it's not visible, anyway. Each one of those triplets of vectors is a latent cluster that brings together queries, features, and search engines into the same latent space. And so what we do here, this is called a parafac or canonical decomposition. And it gives us a latent embedding of queries, features, and search engines into the same latent space. We're mostly interested in the C matrix, which is the search engine by latent cluster matrix, because this tells us how these search engines cluster into these latent topics. And so we're going to take this matrix and we're going to visualize it. And these are the two extreme scenarios that we can take. So let's say we have two search engines and we just plot the two rows of the C matrix against each other. Now, if the two search engines are exactly the same, then the idea is that they will cluster the same all the time. And so you're going to see many dots here on the 0.5, 0.5 if we have only two search engines. Now, on the flip side, if they are extremely different, orthogonal to each other, you're going to see what we have on the right side, where we have points on the axes. And so these are obviously extreme cases, and we are going to observe in the two search engine case points along this sort of diagonal here. But this is sort of a neat tool that takes all this data and helps us visualize the search engines in a common space. And not only that, if we look, each one of these dots is a cluster. And so let's say we observe a cluster that is way off of what we expected. We can then dig into that and see the features that caused this cluster to have a different behavior in the different search engines. So we can do a deeper analysis in the result this way. So is this clear? The second idea is trying to measure a similar thing, but in a slightly different way. So imagine that you have queries, multiple queries, and we can see each query as a class label of a classification problem. So each result is in a feature space, so we can go ahead and learn a classifier from result feature space to query. So query 1 is Sydney, query 2 is, I don't know, Melbourne, and so on. And so if we learn a classifier, let's say on Google results, then we can go ahead and use this classifier on Bing results. Now, if this is successful, how successful that is an indication of how similar these two search engines are in that feature space that we've chosen. And on the flip side, if this fails, this means that the overlap is very low in that feature space. And so for that, we have, obviously this is a multi-class classification problem. It's a hard problem. We chose to use in one versus all a linear SVM in order to do that. And we can measure, for example, the area under the curve or the ROC curve to have an idea of the overlap using the classification accuracy as a surrogate for that. So having presented the tools, let's see how Google and Bing compare using those tools. And for that, we need queries, right? So we decided on two sets of queries. One of them comes from Google Trends, April 2014. These are about 40 queries. They were highly popular, and they are called the head queries. So you can imagine that the search engine have a lot of data, a lot of click data, and so on for these queries. The other set, we call them trunk because they span the entire spectrum of popularity. And we mostly chose them to be able to have sanity checks, so to understand why the query caused this result. And so we analyze these two query sets differently, and I'm going to show you the results in a few slides from now. So, we use the public APIs, and we did that in order to sort of avoid personalization because we didn't access anything from any browser, no cookies were involved. And we was probing the search engines, excuse me, every day for about a month last summer. Now, we restricted what we took for the top 10 results because studies say that if you look further, you're very desperate. And so actually, you're going to rewrite the query instead of clicking on next page. And so we decided that top 10 was a good cutoff. And as I said, we did our best to have as least personalized results as possible, but we can never guarantee that they're not personalized at all. Now, I talked about a feature representation, and in particular, what we used after some thought was a snippet text. And why is that? So first of all, what we do is we take the top 10 results, we take the snippets, which is the small piece of text under the result, under the title, and we just concatenate it into a big document. And so we take that, and we just have a huge bag of words representation of it, which is the feature representation of the result. Now, why do we do that? Why snippets? First of all, eye tracking studies at CHI have shown that people actually look on the snippet and the title mostly to decide where to click. So snippet is actually a good signal on whether the result is informative and the user is interested in it. And another issue is that URL comparison is not a simple string comparison. So it's actually a hard problem because you might have multiple URLs pointing to different pages, to the same page, I'm sorry, or URL shorteners and things like that. And so because there is no bulletproof solution to this problem, we decided to avoid it altogether. But before we did that, we wanted to test whether doing that is not a terribly stupid idea. And actually, it turns out that if you correlate, if you look at manually labeled URL similarities, which is on the x-axis, and cosine similarity of the snippet text, it actually correlates pretty well. And so this convinced us that this was a good idea to use the snippets as a surrogate for the representation of the result. Now, here are the results for Google and Bing using the tensor analysis tool. And on the left, you can see the trend set, which is the highly popular set. And you see that all the points are, around the 0.5, in the center of the graph. And so this tells me that the cluster with very similar membership cluster all at the same time. And so this means that Google and Bing highly overlap for very popular queries. On the flip side, on the other side, we have the trunk set, which you see that the dots are a little bit more dispersed, but there still is some concentration on the 0.5, 0.5. And so the takeaway here is that there is a significant amount of overlap, especially for the head queries. Now, the same sort of result is here on this is the ROC curve for the learning of the classification tool. And if you don't remember what that is, the higher you are close to the upper left corner, the better you're doing. And so you can see that some of the classifiers actually are, touching the axis. And so with the exception of this line here, which is predicting Google using Bing on the manual set, the trunk set, the classification accuracy is pretty high. And so this is, again, another indication of a strong overlap. And so given all this overlap, a natural question arises. So what can we do to alleviate that? What can we do to give the people a more diverse source of information? And an idea is, well, what if we use social media? And so here we define what we call social pulse, which is a very, very simple Twitter-based web search engine. And disclaimer, we're not trying to make the best Twitter search engine possible. We're just trying to to see whether simple social signals can actually help web search results. And so the idea is very simple. We just take tweets that contain the query word or the query noun phrase, and we just rank them by number of retweets or number of appearances. And that's it. So we just take both tweets that contain a URL and also tweets that do not contain one. We just concatenate them, and we take the top 10. And this is what the results of the social pulse are. And because we have the temporal component, we just restrict the daily results to the last 24 hours. And as I said, this is a very simple, rudimentary social signal we're trying to see if we can exploit. And here are the results. So you see that in contrast to the previous case, you see that there are a lot of individual topics, individual clusters on either Google or Twitter for both types of query sets. And it's the same for Bing. So you see that for Bing, it's also the dispersion is more prominent. And so the overlap is definitely not as strong. It's much, much weaker than Bing and Google. And so this is a really encouraging signal, which is reinforced by the classification accuracy. So here we try to predict Twitter results using Google and vice versa. And you see that actually these lines are horrible. These are even worse than the random classifier. But because this is a multi-class problem, we cannot just flip the decision. And the story is the same for Twitter and Bing. And so the overlap is low. And so first part of the mission is successful. We showed that they are different. But this doesn't mean anything really, because I could just give you a random result, and this would be different with very high probability. And so the question is, are they also useful? And so for that, we did an Amazon Mechanical Turk study where we showed results of this search engine to Turkers, and we asked them to rate them whether they were informative or not. And after some thought, this is what they were seeing. So they were seeing the query here, so World Bank in this case, and the snippet. And then we asked them first if they think if it's not informative, so that we don't bias the yes answer. Then if it's informative or whether they don't know. And we also asked them to explain why they think so. And we rejected answers that had no explanation. Sorry. And actually, this turned out to be, this explanation part turned out to be very useful to have high-quality judgments. And we asked for 10 Turkers per result. We didn't get, for all results, the same amount, but all results have 5 or more Turkers. And the agreement is a fair amount of agreement, around 40% flies kappa, which is quite good in this exploratory task. Now, let me show you the results. So here are some anecdotal results where unanimously the Turkers thought that they were useful. And so you see, here is a query about debt, and there's a nice article here that talks about world debt. And everybody thought that this is informative. And so on. I'm not going to go through all the details, but you can see that this text actually looks also not very messy, as you would expect from Twitter text. Now, we also have cases where judges are torn, and these are the low agreement results, where this first result is actually my favorite because this is a quote, And half of the people said, no, this is a quote. This is not informative. I don't care about this. And the other half said, yes, it's informative because it's a quote. And so you see that this is sort of the limitation of asking people this open-ended question. But as you'll see in the next slide, the results are quite encouraging because here's the usefulness per query. And usefulness is simply on average, how many times the majority of the Turkers thought for each query that a result was useful. And so for Barack Obama, for example, all the time, all the results were deemed useful by the majority of the Turkers. And for the vast majority of the queries here, this is the trends queries. You see that the quality of the results is quite high. And the same story goes for the less popular queries or more open-ended queries, as you can see down here. Where, of course, the quality degrades a little bit, but still remains high, even though they're quite, they span the popularity spectrum. And by that, I would like to conclude by saying that in this work, we have a twofold contribution. First of all, we provide tools that you can go ahead and use on your favorite search engines and see how they overlap, how they compare against each other. And furthermore, we showed that, especially for very popular queries, Google and Bing have very high overlap. And this begs the open question that we try to attack, whether we can actually use other signals, like social signals, to provide useful yet diverse results. And it turns out that Twitter can actually be a useful source of information to diversify web search results. And we sincerely hope we cannot do much about it because we're neither Google or Bing, but we hope that this can spark research also on ranking Twitter content in better ways, understanding the intent of the user when they query something on Twitter, versus querying something on Google or Bing, but also start intermixing social signals and social results in the results of the organic results of web search. And by that, I'd like to thank my good-looking co-authors, and I'd be glad to answer any questions if you have any.
Thank you. So 3 minutes left. Any questions?
So have you looked into some of the already existing Twitter search engines? Like, I remember there is one work in Sigayar 2012. It's called Cognos. So that's that beats the Twitter's search engine itself. I think that's the state of the art.
Okay, so I'm not familiar with this particular result, but we have compared against results of other groups that use Twitter as comparing Twitter on Bing, for example, and we found we have similar findings. But I'm not. What is the ranking function that they use? Are you familiar? Do you remember?
I have not read the paper,
Okay.
but I think so they use the list information as far as I remember. Okay. So they don't use the direct tweeted text, which is most of the times misleading. So that's why they use the list information of the users and use that as a curate on that.
I see. That's very interesting. I'll look into it. But the purpose of this, again, is not to be the state-of-the-art Twitter search engine, but rather to show that a very, brain-dead signal like that, the number of retweets, can actually provide really good results. But thank you for the pointer.
Any other question? Okay, one more question.
Was the evaluation done at the user level, or were there any large-scale A/B tests?
The evaluation that we did it was on the user level. It was just Amazon Turk study. Yeah. We didn't have time to do A/B tests, but that would be the way to go. That's a great point.
Okay, thank you very much.